Okay, so hello and welcome. In this video, we're going to look at what we call function notation. I'm not going to go into too much detail about function notation. Um, I'm not going to go into too much detail because we will address it very clearly and more comprehensively when we deal with the section on functions. For now, I just want to talk about how do we evaluate algebraic expressions that are expressed when they look like functions. Okay. Um, so I'm going to use a simple example here. I'm going to give this function, I'm going to call it f of x. This is read as f of x. It's read as f of x, right? And I'm saying f of x is equal to 8 minus 3 multiplied by x. Okay, so if we actually read this, we are saying that I'm going to call this expression f, right? And I say that f is a function of x. In other words, x, or this whole thing that I call f, it takes in certain values. It takes in certain x values, right? And remember, x is a variable. It can take on different values. For example, it can take on the value 1, can take on the value 2, could take on the value 3, and so forth, right? And if I evaluate this, I'm going to say it's 8 minus 3. I'm going to evaluate it at 1. Then it's 8 minus 3 times 1, which gives me 8 minus 3, which is equal to 5. Okay? If I evaluate that exact expression using 2, I'm going to say it's 8 minus 3 multiplied by 2, which is equal to 8 minus 3 times 2 is 6, which is equal to then 2, and so forth, right? What I'm trying to elaborate at this point is just what function notation looks like. I'm saying f of x is equal to 8 minus 3 multiplied by x. This is read as f of x, or f is a function of x. In other words, it takes in certain x values. Okay, so let's talk about how you evaluate it. Well, earlier I said x could take on values such as 1, it could take on values such as 2, and these values are arbitrary. I could choose any value and just throw it in there, and I could see what f of x is going to throw out, right? Okay, so another way to say let's evaluate this at 1 is to say find f of 1. In other words, evaluate the function f of x at 1. And that means wherever I see x, I need to put in the value 1. So I'm going to say that's 8 minus 3 multiplied by 1, which is equal to 8 minus 3, which is equal to 5. Okay, right. What about evaluating f of 2? Well, it's pretty simple. It means wherever I see x, I need to put in the value of 2. So I say 8 minus 3 multiplied by 2, which is equal to 8 minus 3 times, oops, I'm rewriting that, but it's fine. That's 8 minus 6, which is equal to 2. Okay, now let's look at another one. Let's say f of 5. And that's going to be 8 minus 3 multiplied by 5. And 8 minus 15 is equal to negative 7. Okay, so that's how we evaluate functions, or rather algebraic expressions that are expressed in terms of functions. So let's look at a few more examples. Right, here's a tricky one. Find the value of f equals a half. Find the value of f of a half if f of x is equal to x squared minus 2x. Right. Well, that just means wherever I see the value of x, I need to replace that with a half. And not just here, not just in f of x, I need to replace it in the actual expression itself. So now I say f of a half is equal to, I'm going to substitute a half into x. And remember, the x is being replaced with a half. The square is still there, minus 2 multiplied by a half. Now let's work this out. A half multiplied by a half, remember this is actually just multiplying fractions. This is just, if I have a half multiplied by a half, I just multiply the tops with the tops. That's how you multiply fractions, and the bottoms with the bottoms. So that's 1 over 4. 2 times 2 is 4. 1 times 1 is 1. So let's go 1 back. That means that a half squared is equal to a half times a half, which is equal to a quarter. Right. So this is going to be 1/4 minus 2 multiplied by a half, and that is equal to 1/4. 2 times a half is equal to 1. If you're not sure, you can just do it over here. 2 over 1, because that's the same as 2 multiplied by a half, gives you 2 over 2, tops of the tops, bottoms of the bottoms, and 2 over 2 is equal to 1. So that's 1/4 minus 1, which is equal to negative 3/4 remaining. Okay, let's look at another example quickly. Find the value of g of 3. Now, what in the world? We just went from f of x. Now we're busy with g of 3. What's going on? Well, I'm saying find the value of g of 3 if g of x, if what? G of x is equal to negative 3 x squared minus 2 multiplied by x. And what does that equal? Well, that just says wherever I see x, we need to put the value of 3 in, and all we did was we just gave this function a different name. It's an easy way to keep track of things. Sometimes I call it g, sometimes I call it f, sometimes I call it e, sometimes I call it d, sometimes I call it a, whatever it may be. All I'm saying is that g, or function little g, is a function of x. It means I throw in an x of a specific value and I'm going to get out a g of x value. So what is this going to be? Well, g of 3 is equal to negative 3 multiplied by 3 all squared minus 2 multiplied by 3. And let's work that out. That's minus 3, and I first have to do the things that involve the exponents or the powers. 3 squared is 3 times 3, which is 9, minus 2 times 3. So let's work this out. Minus 3 times 9 is negative times a positive is negative. 3 times 9 is 27, and negative times a positive is negative again, and 2 times 3 is equal to 6. That's going to give me an answer. 6 plus 7 is 13. So that's going to give me negative 33. And that's my final answer. Now I've got one for you to try, and then we have a worksheet for you to continue with. So I'm going to say evaluate the following. And this one, I'm going to give you some hints, right? I want you to tell me the value of g of naught, right, plus 2 times f of 1, right, if I give you that g of x is equal to x squared. Let's just erase that and do that part over. G of x is equal to x squared plus 1, and f of x is equal to 2x minus 1. So I'm going to give you a hint. I'm going to tell you that this is the thing you're evaluating. So you need to find the value of g of naught plus 2f1. This means 2 multiplied by f of 1. Okay, so I suggest you pause the video over there and give it a shot on your own. Just try it. And then when we come back, I may just give you the answer. Don't peek. I thought you were going to try it on your own. Oh, you did try it on your own. Okay, so let's see if your answer matches my answer. Okay. Well, I need to take the equation of g of x, right? And I need to replace wherever I see x with 0. So I'm going to say I need to put in g of 0, right? Which means wherever I see x in that equation, I'm going to substitute in 0. So that means I'm going to take x squared plus 1, and I'm going to make the x squared 0 squared plus 1. And on this side, I'm going to say it's plus 2 because that's part of the expression I want to evaluate over here, multiplied by f of 1. But f of 1 is equal to 2 multiplied by 1 minus 1, close bracket. 0 squared is just 0. 0 plus 1 is 1, plus 2, and let's simplify this bracket. 2 times 1 is 2. 2 minus 1 is just 1. And therefore I get 1 plus 2 times 1 is equal to 3. Right. Because 2 times 1 is just 2. I'm going to erase this over here. Then we can say that equals 3. Okay. Now last thing, as a quick recap, I hope you got that and I hope you understood it. I'm going to give you an example. If I say f of x is equal to x plus 4, then you must tell me what f of 1 will be. That's just 1 plus 4 is equal to 5. What's f of 2? That's 2 plus 4, which is equal to 6. What is f of 3? Well, that just means you replace x with the value of 3, which becomes 3 plus 4, which is equal to 7. And what is f of heart? F of heart, what does that equal? Well, you can say, well, that just means, Imad, you need to replace the x with a heart. So that's heart plus 4. Okay. And in this case, I can't really go further because I don't know the exact value of heart. I don't even know if it's modifying the same noun or if it's in the same unit. But that's the basic idea with evaluating algebraic expressions using function notation.